Hi, and welcome to Gaming with EaselJS, an advanced Canvas course on Tuts+. In this lesson, we'll pick up where we left off from the last lesson. If you remember, we created an action service that would track keyboard keys to increase and decrease the X position of the hero. Now, what we really want for a space shooter is for left and right to rotate the spaceship, and for up and down to move the ship in the direction that it's facing. It would also be nice if this movement had some kind of inertia to it and acceleration. In space there's very little friction, so even when we lift our hand off the forward key, the spaceship should continue moving forward for a little bit. So assuming you've got your grunt task running, let's have a look at the code. Before we start, let's tidy up a little bit. We'll move all of this setup of the graphics of our hero into a function called prepareBody. We can then call prepareBody using the call function so that we can pass in the context. That way we can keep our code the same, referring to this, with this referring to the hero instance. Now we're going to create another one called prepareProperties. In this function we're going to set up all the initial properties of our hero. I've named these with an underscore because they're kind of like private methods. They're not exposed outside of the hero instance, but they're used with the hero instance as the context. So here are the properties we're going to need set up from the beginning. Our hero will have a name, hero. We can use that later on when we want to identify the object. We will have thrust. We'll use this value to determine whether or not our hero is accelerating. It will equal either 1, -1, or 0, depending on if he's moving forward, backward, or not increasing speed. It basically correlates to the use of the up and down arrow keys. Then we'll have heading. This will determine whether our hero is rotating left or right. Once again, this will be either a 1, a -1, or a 0. And this one correlates to the left and right keys. Next we have the actual rotation at any given time of our hero. This value is actually a container property and will determine the rotation of our hero. Then we have vrot. This is the velocity of the rotation, how much the rotation is changing in any given frame or tick. We have the same for x and y, how much our hero's position is changing in the x and y axis in any given tick. And then we have our actual x and y values. So we'll want to pass in x and y when we call prepareProperties. So given that we have a bit of a correlation already between thrust and heading and the directional arrow keys, we can see already that there might be a simple way that we can turn those arrow keys into actions that actually change our hero's properties, which can then be acted on in the tick handler. We're going to write a function called processActions, another kind of private method that will take the actions from the action service and set the thrust and heading correctly depending on what actions it finds. To organize our rules of what keys should affect what properties, we're going to create another object hash. So our object is going to be made up of properties that match up with the different keys in the action service, and then each of these keys is going to have a corresponding object that will have a property on the hero that needs to be set and the value that it needs to be set to. For move right, we want to change the heading as well, but we want to set the value to 1. Up is thrust, set to -1, and down is thrust set to 0.5. I figure that a spaceship can't travel as fast backward as it can forward. Also take note that our value for up is -1. This is because of the direction of the axis in the canvas environment. So, in our processActions function, we want to firstly get the actions. Next we need to set thrust and heading to 0. This way we only set them to 1 or -1 if they've appeared in the action service and they match up to one of our properties here. Now we need to iterate over each key in the actions that we received, so that's basically each action. If actions has own property of key, we do this so that we avoid iterating over non-enumerable properties. We do this so that we avoid iterating over inherited properties, and then we basically get the key action from the key actions hash using the key action that is currently pressed. If we get a corresponding key action, we will set the property defined here, but we're setting it on our hero, equal to the key action value. So if we call this in our tick, the context of the hero, we can be assured at the start of every tick we'll have all of our actions processed and the corresponding values on our hero already set. So now it's time to do something with this thrust and heading information to send our little spaceship off around the galaxy. Now, before we start actually implementing those algorithms, we're going to need a couple of constants. We will need the speed of our spaceship, its rotational speed, the inertia that it has, and its rotational inertia. Now, I'm not really an expert at physics, so I can't really be sure that inertia is the right name, or whether it should be friction or something else. But basically, it's how much our hero moves along or continues to rotate after we've stopped pressing on the keys. So basically, our aim for our movement algorithms is to set the vrot, vx, and vy values, which can then be used to increment our real rotation and x and y values. So at the start of every tick, we can set our rotation equal to rotation plus this dot vrot, which is our change in rotation, and times it by our rotation speed as well. And we can also set y to y plus vy and x to x plus vx. So that's great, but how do we get these values? Well, for the v rotation, it's fairly simple. We increment vrot by this dot heading, and then we times the vrot value by rotational inertia. This is to ensure that our spaceship just doesn't keep spinning and spinning forever. Our x and y values are a little more complex. We're going to need to use some trigonometry. Now, we won't go into too much detail, but just to give you a general idea of what we're doing, I've gone to mathisfun.com, sine, cosine, and tangent. Now, we want to send our spaceship off in the direction that it's currently facing based on its rotation. Now, we have its rotation, so if you think about the spaceship being at this corner here, we can work out how much we need to increment x and y in order to make it appear as if it's traveling in the same direction that it's facing. We have this angle here, in this example 30 degrees, and what we want to get is this length and this length here. Now, of course, we don't know how far we're going to move in any given direction, so we're not really getting a length, but what we are getting is an x and y ratio, and then we can multiply that by any number to get an actual position to move to. So to get our x ratio, we need to use math.sine and then pass in the rotation. But we can't pass in the rotation in degrees, we need it in radians. To convert the degrees into radians, we need to multiply rotation by math pi and then divide it by negative 180. We can then times it by our thrust and we'll be correctly setting the direction of our x ratio movement. We can do the same for ratio y, but using cos, and then we can get the diff of what we want to move by multiplying this ratio by speed. Now, to give a feeling of acceleration, we have this diff value here, and we're going to increment our vx and vy by this diff. Rather than just setting vx and vy to diff, this will give us a proper feeling of acceleration and deceleration. Then we can multiply our vx and vy by inertia to ensure that we have something slowing us down. If we look at our little square now, you'll see that when we hit left and right, we rotate, and when we hit forward, we accelerate. As you can see, this gives us quite fluid movement and definitely gives some sense of being out in space. Well, that's all for this lesson. Check back in for the next lesson where we'll be looking at mouse interaction. Ciao!